All right, good morning, guys. Doing this note sheet for the 7F notes here. Should be pretty simple. We're just talking about angles in circles, whether they're um, on the circle, inside the circle, or outside the circle. Should be pretty simple deal here. Okay. First type of angle is an inscribed angle, an angle where the vertex is on the circle. All right. So if I were to draw, I'm gonna turn this webcam off here. So if I were to draw up a circle right here like this, and let's say I put an angle A where the vertex is on the circle. All right, so there's that. All right, the measure of angle A is going to be half of the arc that it intercepts. So if I look at angle A and the blue lines that come from it, this would be the intercepted arc right here. Okay, so that is the whole intercepted arc right there. And let's just say hypothetically that intercepted arc is 280 degrees. All right. So this arc from this point to this point is 280 degrees all the way over there, okay? Well, angle A is going to be half of that. So angle A is going to be 140 degrees, okay? And so that's just the rule. When the vertex is on a circle, okay, it's called an inscribed angle, and the angle is half the length of the arc that it intercepts, okay? Very simple thing. All right. If we look at another one here, now let's just say the vertex is on the circle and we see something like this, right, where part of it's on and part of it's off. Well, still the same kind of deal applies here. Okay, so if I have um, a 80-degree angle right there on the circle, all right, it's going to be 160-degree arc. Okay, uh, pretty simple stuff. Okay, so that is that for right now. Let me go on to the next thing here, which is an angle where the chord is, or excuse me, an angle where we have two chords. Okay. So here, an angle inside a circle formed by two chords is going to be half of the sum of the intercepted arc and the intercepted arc of the vertical angle. So here's what I mean by that. I'm just going to stay on this picture here. All right. So if I'm looking at this angle X is on the interior of a circle. The vertex is on the interior of a circle, right? So I'm looking at angle X, and I also want to look at the angle that's vertical to X, which is also has the same measure as X, because again, vertical angles are congruent to each other. Okay. So if I'm looking at X, it's gonna go to this 90-degree arc, and it's also gonna go to this 50-degree arc. Okay. So X is gonna be 90 plus 50 in parentheses divided by 2. Okay. 90 plus 50 divided by 2 for angle X, which would be 70 degrees. Because again, to go over it one more time, all right, we see angle X, and it's kind of difficult to see here, goes with that 90-degree angle, or that 90-degree arc, okay? The vertical angle at angle X, which is over here, goes to the 50 degrees, okay? So we're going to do 90 plus 50 in parentheses divided by 2, and we get a 70-degree angle there. Now, if we're looking for Y, okay, well, angle Y goes with the 60-degree arc, and then the vertical angle at angle Y goes to 160-degree arc, okay? So we're going to have 60 plus 160 divided by 2, which of course is going to be 110 degrees. All right, so 60 plus 160 divided by 2 is 110. And it should add, because remember, X and Y form a line, so X and Y together should add up to 180, which they do. So that's another way to sort of make sure that your angles are right if you sort of do that there. Okay. Lastly, if an angle is on the outside of a circle, the measure is going to be half the difference half the difference of the intercepted arcs. Okay, half the difference. All right. So if I go back to the other page here where I have a little bit more room to work with. So I have a circle. There's an angle A. All right. Let's say this arc here is 90 degrees. Let's say this arc here is 12 degrees. Okay. So angle A, okay, angle A is going to be arc minus arc divided by 2. So it'll be 90 minus 12 divided by 2. Okay, so 90 minus 12, which is 78, divided by 2, which would be, I believe, a 39-degree angle. Okay, so big arc out here minus a little arc divided by 2 gives us our angle. If we ever have to work backwards, okay, we'll times it by 2, and then we'll solve the equation sort of up there. All right, we'll talk about that a little bit later. Again, if we have another circle here, let's say we have a circle and we have an angle out here. All right, let's say something like this, okay? Well, here's our arc number 1. And this would be our arc number 2 right there, okay? So you have to just trace out these secant segments right here. All right, trace them out, okay, to where they intersect the circle at the big arc and the little arc. So again, what we'll do there is we'll do arc, that arc minus a little pink arc. That big arc minus the pink arc, and then we'll divide that all by 2. That would equal angle A, whatever that is, okay? So that's that. Again, if we're working backwards, let's just say, we have something like let's just say they give us a 40-degree angle right here. And let's say this is a 60-degree arc right there, and we got to find this missing arc right here, okay? We know that if they give us the angle and we got to find the arc, we're going to have to do the angle times 2 first, okay? So 40 times 2, because we're working backwards, which is 80. All right, and we know the interior angle is the sum of the other two, so it'd be 60 plus that missing thing right there, and then we would just solve it backwards. We get 20, and it should be pretty simple from there. All right. So that is all I have right now. You guys let me know if you have any questions, and you have a good day. Thank you.